Second condition, two sources must be monochromatic. Monochromatic means single color. So if two sources are of multiple color, then chances are there one color may give your ear brightness. That means if lambda is 100 is bright and a color gets changed to some other one where lambda is 150. Now clear cut, this 150 is 3 by 2 times of 100. So this becomes odd multiple of the wavelength. Hello?
Yes, sir.
If it is odd multiple of half the wavelength, then point will be bright or dark?
Dark.
Dark. मतलब जो पहला ब्राइट था दूसरे कलर से वही डार्क हो जाए, तो पैटर्न क्लियर नहीं होगा ना, कभी वही ब्राइट बनता है कभी वही डार्क. लेकिन सिंगल कलर का है तो जिधर ब्राइट है वो ब्राइट ही रहेगा, डार्क है तो डार्क रहेगा. इट वोंट चेंज बिकॉज यू आर नॉट चेंजिंग द वेवलेंथ. सो टू सोर्सेस मस्ट बी मोनोक्रोमैटिक. अब इसका रीजन, इफ सोर्सेस आर नॉट monochromatic, then at same point brightness and darkness both can be produced. Hence pattern will not be clear. Got it? Meaning at same point we can have bright and dark both, तो pattern clear नहीं लगेगा. Hello?
Yes, sir.
Done, sir.
Third point. Two sources must be narrow. That means these two sources must be narrow, जिधर से लाइट जाने वाला है. अगर वाइड है तो क्या होएगा? If sources are wide, then at the same point P, if this first and first meets, suppose it gives bright, and first and last meets, then it may give dark because दोनों का रास्ता अलग है, अभी सेम नहीं. बट अगर एकदम नैरो रहेगा तो ये एक ही दिख रहा है ना मुझे, तो रास्ते का डिस्टेंस सेम, तो पाथ डिफरेंस विल नॉट वेरी, पॉइंट विल बी सेम, आइदर ब्राइट और डार्क. So two sources must be narrow. If sources are wide, then at same point we can get brightness or darkness. Hence, pattern will not be clear. Hence, pattern will not be clear. Right.
Done, sir.
So 3 points we got so far. 4. Total there are 6 points. Amplitude of two light waves must be same. If they are not same, then you can't get complete dark. Because अगर ये 3 है and trough 2.9, तो 0.1 का वजह से थोड़ा तो light आएगा. We can't get complete darkness. The amplitude of two light waves must be same. Reason I am writing, in order to get complete darkness during destructive interference. Reason you will not write if they have not asked. In order to obtain complete darkness during destructive interference. Right, 4th point. 5th and 6th ka reason will remain same. So copy 5th, 4th one, then I am explaining 5th and 6th. Done? Yes, done?
Yes, sir. Done.
Just check what I am writing. Can you see this? क्या लिखा है? क्या लिखा है ये? Can you see?
ABC.
क्या बात कर रहे हो? KBC? KBC?
ABC.
ABC, अच्छा. But had I written this with proper gapping in between, तो एकदम clear दिखता ना आपको ABC?
Yes.
That means if this is screen, ये पूरा पर्दा है अपना screen. इधर मैं एक छोटा पार्ट लेता हूँ. ये रहा show bright. ये bright है. फिर बीच में dark. फिर bright. फिर bright. फिर dark. फिर bright. ऐसा ओवरलैपिंग लग रहा है ना थोड़ा. ओवरलैपिंग लग रहा है ना, एक के ऊपर एक ऐसा दिख रहा है ना.
Yes, sir.
बट अगर गैप ज्यादा रहेगा तो नहीं लगेगा ना ओवरलैपिंग ऐसा. तो नेक्स्ट पॉइंट है ये गैपिंग किसके वजह से ज्यादा होगा, वो कॉन्सेप्ट वाला है नेक्स्ट. सो 5th and 6th point I am right. 5th, the distances between two coherent sources must be small. We are going to prove दो ब्राइट और डार्क का बीच का फॉर्मूला विल कम लैम्बडा डी बाई डी. डी इज डिस्टेंस बिटवीन टू सोर्सेस. ये सोर्स और स्क्रीन के बीच में है. तो फ्रिंज विड्थ, इसको फ्रिंज विड्थ बोलते हैं. मतलब दो ब्राइट का बीच का डिस्टेंस और दो डार्क के बीच का डिस्टेंस. So inversely we are getting na fringe width is inversely proportional to D. So can I say if D decreases then width will increase? Hello?
Yes, sir.
So in order to get larger bandwidth, the distance between source must be small. Why? In order to get larger bandwidth or fringe width, they are same. 6. The distance between source and screen must be large. Again, reason same, in order to get larger bandwidth. Copy.
Done, sir.
Okay. So all the 6 points we have done. Explain analytically. See, whatever I'm doing in the class, if you don't practice 2 times now, you'll forget. Explain analytically formation of interference of light. Explain analytically formation of interference pattern of light. To get interference pattern, we require how many light? 2 or 1?
2.
2. Obtained from which source? Coherent, na?
Yes.
Coherent. So keeping that in mind, I'm starting like this. Consider 2 coherent sources, S1, S2, separated by very small distance d, illuminated by monochromatic light of wavelength lambda. Let the screen be placed at very large distance d. Draw S1M, S2N perpendicular to the screen. Also draw seg OP perpendicular bisector of S1, S2. Therefore, PM will be Pn equal to d by 2. Let Q be a point on the screen at a distance x from P. Draw S1Q, S2Q. The waves starting from S1, S2 reaches point Q after traveling distance S1Q and S2Q. Thus, path difference at Q will be S2Q minus S1Q. If this is N lambda, point will be bright. If it is odd multiple of half the wavelength, point will be dark. Hello?
Yes, sir.
That means we have ensured that we can get bright and dark at point Q. So just draw the diagram, then I'm explaining further. Once you complete the diagram, then please tell, huh?
Done, sir.
This is sometimes also called as Young's double slit experiment. Huh? Double slit means two opening through which light is allowed to pass. Can I clear the diagram now? Can I clear the diagram? Hello?
Yes, sir.
See. This derivation is of 4 marks. consider two coherent sources S1, S2 separated by very small distance d, illuminated by light of wavelength lambda, illuminated by monochromatic light of wavelength lambda. Let D be the distance of screen from source. Draw S1m, S2n perpendicular to the screen. Also draw seg OP perpendicular bisector of S1, S2. Therefore, PM equals to PN equals to D by 2. Let Q be a point on the screen at distance X from P. Complete this much again.
wavelengths.
Okay. Let Q be a point on the screen at distance x from P. Draw S1Q, comma S2Q. The waves starting from S1, comma S2 reaches point Q after traveling distances of S1Q, comma S2Q respectively. Draw S1Q, S2Q. The wave starting from S1, S2 reaches point Q after traveling distance S1Q, S2Q respectively. Thus, path difference at Q due to two waves will be S2Q minus S1Q. If S2Q minus S1Q equals to n lambda, where n equal to 0, 1, 2, dot, 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 then point Q will be bright points. Q will be bright point. If S2Q minus S1Q is odd multiple of half the wavelength n equal to 1, 2, dot, 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 then point Q will be a dark point. Copy till this. कभी भी आओ, आपको भी तो कितनी बार बोला है पाटिल। हाँ कभी भी आओ चलो। और मुलुंड का थोड़ा मुझे नोटिस बोर्ड तो बना दीजिए। हाँ ओके।
Done, sir.
Okay. Now we are interested in measuring this S2Q and S1Q so that we can subtract and find the answer. Can we see the light? That means if this is S1, this is S2. Can you see how it is traveling this way or this way or this way? We are assuming no, it is going like this. But can I see it?
No.
No. But definitely on this screen, this capital D I can measure, na? Capital D by scale.
Yes, sir.
And this X also I can measure, na? Hello?
Yes.
And source ka beech ka distance also I can measure. So I should get my S2Q minus S1Q in measurable quantities. अगर ये सब मेजर करके आंसर मिल रहा है मुझे 3 लैम्डा पाथ डिफरेंस, तो मैं बोलूंगा ब्राइट है. 3 लैम्डा बाई 2 मिलेगा तो डार्क है. बराबर?
Yes, sir.
ओके. These are which type of triangle? S2NQ and S1MQ.
Right angle triangle.
So can I use Pythagoras theorem?
Yes, sir.
If I use Pythagoras theorem, can I get S2Q?
Yes.
Same way I can get S1Q.
Yes, sir.
Yes.
Okay. In a right angled triangle S2NQ by Pythagoras theorem. S2Q square is S2N square plus NQ square. S2Q square is D square plus, this is X plus D by 2. Correct? Is it X plus D by 2?
Yes, sir.
Okay. Then in a right angle triangle S1MQ by Pythagoras theorem, S1Q square will be S1M square plus QM square. So S1Q square is D square plus X minus D by 2 square is QM. Subtracting 2 from 1, we get S2Q square minus S1Q square is D square plus X plus D square minus D square minus of D by 2 square. This will get cancelled. So S2Q square minus S1Q square is X square plus XD plus D square by 4 minus X square plus XD minus of D square by 4. D square by 4, D square by 4, X square gets cancelled. S2Q square minus S1Q square is 2XD. Again, any doubt till this? Hello?
No, sir.
Copy.
Done, sir.
Okay. S2Q minus S2Q and S2Q plus S1Q is 2xd. We are interested in difference. So S2Q minus S1Q will be 2xd upon S1Q plus S2Q. Very small assumption. Since capital D is very, very large than small d and very, very large than x, S1Q we can take approximately S2Q, which is approximately D, means D. D is very small, capital D is very large. This is, have you seen microscope?
Yes, sir.
So in that microscope, the lenses are too small. तो हम लोग को बहुत छोटा गैप से आई पीस होता है ना, ऐसा छोटा, जिधर से हम लोग देखते हैं. 3-4 जन मिलके एक साथ देखते हैं क्या?
Only one.
Only one. मतलब that distance is very small. इधर बीच में किधर तो Q है. So this line will be almost parallel ना. और डायग्राम में हम लोग ने थोड़ा enlarge दिखाया था. Because the distance are in 0.1 millimeter, 0.2 millimeter ऐसे. So these three lines, are they almost same?
Yes.
Yes, sir.
तो इसलिए बोला approximately D. तो ये assumption है इसमें. अगर ये distance capital D nearly 4 times small d से बड़ा नहीं होगा तो मत यूज करना ये प्रॉपर्टी. So S2Q minus S1Q will become 2xd upon d plus d. So S2Q minus S1Q is 2xd upon 2d. So S2Q minus S1Q equals to x d by d. This we got path difference x d by d. So path difference is S2 minus S1Q or x d by d. Thus, this so we can measure, na? X, d and d all we can measure, equal to n lambda, where n is 0, 1, 2, dot, dot, dot. Then point Q will be a bright point. Point Q will be a bright point. If x d by d is odd multiple of half the wavelength, n equals to 1 to dot, 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 then point Q will be a dark point. Yes, copy till this, then we'll summarize after this. So we got x d by d we can calculate. Hence path difference we can calculate. Last few lines to conclude, we are getting interference pattern. We will get interference that we got, ये bright dark मिलेगा. ये point P S1 S2 का बाइसेक्टर पे है ना, ये परपेंडिकुलर बाइसेक्टर. So S1P S2P distance are same or different? Point P lies on perpendicular bisector, so they are equidistant from S1 S2, or it is not?
Equal.
Equidistant, that is property. If point lies on perpendicular bisector, then it is at same distance from end point. That is perpendicular bisector theorem, which you might have studied in 8th 9th. तो डिफरेंस जीरो होएगा ना इधर, पाथ डिफरेंस. अगर
Yes, sir.
जीरो होएगा तो ये पॉइंट ब्राइट रहेगा ना हमेशा. ये तो फिक्स है ना इधर P स्क्रीन के ऊपर. तो कैन आई से P will be always bright point. Now if I move up, so X value is increasing. If I move down, then also X value is increasing. So D फिक्स है, कैपिटल D फिक्स है, X चेंज हो रहा है. तो कभी कभी वो n लैम्बडा मिलेगा, कभी कभी वो 2n-1 लैम्बडा बाई 2 मिलेगा. तो ब्राइट डार्क ये मिलते रहेगा ना हम लोग को स्क्रीन पे. हेलो.
Yes, sir.
That means if I go on changing the value of X, my path difference will keep on varying, and I will get alternately from center dark, bright, dark, bright, dark, bright, dark, bright on both sides of central bright. On both sides of central bright. Hello.
Yes, sir.
Thus, can I say alternately I got bright and dark band, which is nothing but interference pattern.
Yes, sir.
ये हम लोग ने भी ग्राफ से नहीं, इक्वेशन से निकाला ना, उसको बोलते हैं एनालिटिकल ट्रीटमेंट. सो एट पॉइंट P, path difference will always be zero. Hence, point P is always a bright point called as central bright point. Hence, point P is always a bright point called as central bright point. As value of X is increased alternately, dark and bright points are obtained on both sides of central bright point. Thus, interference pattern is formed. Complete. This is 4-mark derivation. Explain analytically formation of interference pattern of light. Yes, done.
Yes.
Okay. Define fringe width. Distance between consecutive crest and trough is called wavelength. Crest and trough distance is called wavelength.
Yes.
Consecutive crest, that is also called wavelength. Consecutive trough also called wavelength. See, crest and trough wavelength. Consecutive crest wavelength. Consecutive trough wavelength. Correct.
Yes, sir.
So if this is bright, this is dark, bright, dark bands. Dark, bright band. So distance between consecutive bright bands or consecutive dark band or one bright, one dark is called as what? Fringe width. Okay. Hello.
Yes, sir.
Right definition. The distance between consecutive bright bands or consecutive dark bands or distance between one bright and one dark band is called as fringe width or band width. Write down. The distance between consecutive bright or consecutive dark or one bright, one dark band is called as fringe width or band width.
Yes.
Derive expression for fringe width. This is suppose central bright band. First bright, second bright, third, fourth. ऐसा dot dot dot. So if I take distance of second bright and find distance of first bright, subtract दो bright का बीच का distance I will get. Correct? Hello. If I take any bright, suppose n, and one higher bright, xn plus 1, then distance between them is called as what? Fringe width?
Yes, sir.
Okay. So I'm finding formula for nth bright, n plus 1th bright in terms of x, subtract. That will be fringe width. So let xn, comma x suffix n plus 1 be the distances of nth and n plus 1 bright bands from central bright band. We know that for bright bands path difference, comma x d by d is n lambda, where n is 0, 1, 2, dot, dot, dot. So x will become n lambda capital D by d, n is 0, 1, 2, dot, dot, dot. Copy till this. Completed.
Yes, sir.
Therefore, x for n will be n lambda d by d, and n plus 1 will become n plus 1 lambda d by d. Therefore, fringe width I am denoting by x. Some book also denote by w. So it is xn plus 1 minus xn. Therefore, n plus 1 lambda d by d minus n lambda d by d. So it is lambda d by d common, n plus 1 minus n. X is lambda d by d. This is expression for fringe width. Copy till end. Completed?
Yes, sir. Done.
Now, sometimes they will specify derive expression for fringe width using dark band. Not given, you can take any. But if they specify, you can't do anything. So I'm proving also with dark band, we will get same answer. So let xm, comma xm plus 1 be the distances of m and m plus 1 dark bands from central bright band. We know that path difference for dark bands, comma x d by d is odd multiple 2n minus 1 lambda by 2 n equal to 1 2 dot dot dot. So x will become 2n minus 1 lambda by 2 d by d where n equals to 1 2 dot dot dot. So when I put xn ka value m, then this will become 2m minus 1 lambda by 2 d by d. Xm plus 1 will be 2 m plus 1 minus 1 lambda by 2 d by d. That is 2m plus 2 minus 1 lambda by 2 d by d, which will become 2m plus 1 lambda by 2 d by d. So fringe width x equals to xm plus 1 minus xm, that is 2m plus 1 lambda by 2 d by d minus 2m minus 1 lambda by 2 d by d. Please copy this much.
Done, sir.
So whether you use bright band wala formula or dark band, fringe width will not change. It is lambda capital D upon small d. Can I clear?
Yes, sir.
Okay. Note. This is screen, and here are two source. Suppose from here light goes, and here we are getting fringe width of this much width, which is lambda d by d. This is fringe width. This is capital D. This is angle subtended at the slit. Then that angle subtended is called as angular fringe width. Angular fringe width, tan theta is approximately theta, will be x d by d. So we can say theta equals to lambda d by d upon d. Therefore, theta equal to lambda by d. So sometimes they will use this word angular fringe width. That means angle subtended by the fringe at the slit, and then use this formula and get the result. Copy. Only numerical can be asked on this part. Angular fringe width is fringe width upon capital D.
Done, sir.
Okay. Everybody is done.
Yes, sir.
So that's all for today. Revise and be